Hello everyone, my name is Salomon Kim and I've been teaching computer science and physics at IB the Top for now 4 years. One of the major reasons why students don't do computer science a lot, well, first of all, is because a lot of universities demand other sciences in order to apply for certain majors. A lot of people think computer science and coding in general is very difficult. And if they have not studied that before, they think they will not be able to follow the course. Yes, the earlier you learn computer science, the better you will become. The first time it's always hard, but as you learn and time passes, your level will naturally increase. But if the first time you ever learned how to code is in the university, you will be a little bit behind other students who have already learned the same things in high school. All you learn in IB Computer Science in terms of coding is very simple concepts. So you learn first about Java, and the first things you learn are how to do loops, you learn about variables, you learn about arrays and data structures. So all in all, I would not say that it's very difficult. It also depends on the option that you take. One of the options that a lot of computer science courses pick is option D, which is object-oriented programming. And by itself, object-oriented programming is not a very large chapter, or it's not a lot. There's not a lot to learn, but you have to be able to imagine how objects contain data. So for a lot of students, it can be a little bit difficult. Of course, computer science is about coding, but the IB also introduces a lot of theoretical topics, including a lot of ethical considerations, how you include inclusivity, system design. So I would say it's a 50-50. One of the main reasons they tend not to start with Java is that Java has a very high initial, what we call it like a wall, where you have to know quite a lot of things to be able to understand what Java is doing. So what a lot of schools do is they will start with Python, because with Python, it's more flexible. You don't have to pay too much attention to the structure. The code will work even if you are not very strict with your grammar. But here's the thing. If you start learning with Python, it is easier to start. But there are a lot of basics you don't learn because you're not forced to learn them at the beginning. So a lot of people, they start with Python and then they go on to either, first Scratch or Python, and then they go up into Java or C++. Usually, they consider Java to be a little bit easier than C++, because C++ has all the more advanced concepts and you have to know a lot about the hardware. So I would say you should probably hold up learning C and C++ until university. So NetBeans is not a programming language. So the programming language is Java. But you have to write down the code in your computer in another program. So you could use a notepad to write your code, but it would be very hard. So what NetBeans is called development environment. And what it does is it helps you code so it's easier. It tells you when you write something down, if something is wrong, it will tell you something is wrong, tell you what the errors are. And if there's any errors, it will help you or try to help you fix those errors. Now, NetBeans is one of many programs. There is Eclipse, there is Visual Studio Code. Well, every company, you say, has its own development environment. But one of the advantages of using NetBeans is that NetBeans was made by the same company that made Java. So you could say there's a lot fewer errors when you use NetBeans. You don't necessarily have to learn Java. But like I said earlier, there are certain things you would learn by doing Java that you would not learn by learning Python. One of the major things about what you learn with doing Java that you don't learn in Python is something called declarations. And what that means is at the very beginning, you have to tell the computer what are the variables you will use. And that kind of helps you organize your thoughts a little bit because you have a list of everything you use. Python, on the other hand, you don't need to do that. You just use whatever variables you want. But later on, it becomes a little bit hard to keep track of everything you made. That's quite a good question. If you have already learned a little bit of Java, I would say you are basically 70% done with the coding.
Okay.
You would only need to learn a little bit more about data structures. And if you learn data structures and then later you learn about object-oriented programming, like we said before, it was not a very big step forward. Always depends on the student. I've seen some students are very good at memorization. If you're very good at memorization, the theoretical part is very easy. But you cannot memorize the answers to coding problems. But on the other hand, there are a lot of students that are more mathematically inclined. So they can see something and say, oh yes, I can add this, and they can make the code very well. But they're not very good at memorizing concepts. In those cases, the theoretical part is a little bit harder for those students. Particularly in paper 3 problems.
Okay.
You basically have to write a very long essay, yes. And there's a lot of problems even in paper 2 where they ask you for advantages, disadvantages, compare this to that. And a lot of times it just boils down to how well you can express your thoughts logically. Because a lot of the questions, there's no one right answer. It's you give your opinion, and based on that opinion, you just support it with whatever logic you can support it with. If you're really good at writing essays, it's a very big plus when you do computer science as well because of the theoretical part. In paper 3, the last problem is basically maybe 4 to 5 paragraphs long.
One page?
1.5, let's say. Well, it's not hard per se, but they have to have a little bit of imagination. A lot of the questions, like I said before, maybe something they've never seen before, they just have to try to guess as well as they can, or as best as they can, and support it with whatever experiences they can put up, or examples, right? For instance, you could say, why do you think this would be ethically wrong? So there is no right answer about ethics. So you have to think, well, maybe it's because it hurts people, or maybe it's an invasion of privacy. So you have to make something up and support it with whatever examples you can support it with. So they might ask you, okay, what would be the ethical consequences of installing a CCTV camera? But the problem is you cannot just say that, oh yes, invasion of privacy, right? You have to say, why is it an invasion of privacy? How would it be harmful, and how to prevent that? Or how to maybe find a way to install the CCTV camera without running into that problem. Well, it would be the same in any subject. If you have a linguistic handicap, yes, of course, it would be harder to get the highest score. I would not say yes or no to a specific question.
Okay.
Because even though physics doesn't have like long essay forms, you have to have a good handle in language to actually understand the question too. If you don't have the level of English to kind of write an essay, you probably wouldn't be able to understand the questions themselves either. So I would say it's mostly the same. If you don't have a good handle in language, your handicap would be the same either in computer science or physics. So I would say the difference between learning through maybe a hagwon or private tutoring and not doing that and learning by yourself, there's, I think, 2 things that we have to consider.
Okay.
Having a tutor makes the amount of time required to learn something a lot shorter. Because if you do it by yourself, sometimes you'll get stuck and think, I don't know how to do this, I don't know the logic behind this. If someone is there with you to explain to you why this is the way it is, you can save yourself a lot of time. And that, of course, goes a long way, because if you have more time, you can also focus more on other subjects and you do better in general. The second thing about having someone there to kind of guide you is that a lot of the questions and tests have very clear patterns. So for instance, if it's a 2-point question, you always know you have to say what it is and then give an example. 3-point questions, it's state the answer, a reason, and an example. But if you don't know these patterns, well, you just do the best you can and you don't really look at the question, and you will miss a lot of points. So having a little bit of guidance goes a very long ways into getting a higher score in the tests. And finally, one last thing about the having someone guide you is that a lot of times you will sit there and it feels like what you have to learn is very big, and you feel depressed because you feel it's so large you cannot do it. But if someone there knows, no, you don't have to learn like 5 books, it's just learn these 4 things. As long as you know these 4 things, it's better. It makes you feel better as if it's more attainable. So it gives you more motivation and it makes the process a little bit faster as well. The main part there is, let's take for instance, there's one specific concept you don't understand, but you already read the book, you read the explanations. If you still don't understand, you're basically stuck. So someone else has to be able to identify the reason you don't understand. Since it's something that has to do very specific to this one person, it can't be just a general solution you can find out there. Somebody has to know you, he has to know your level, he has to understand what is preventing you from understanding and give you the appropriate explanation to get you to that level of understanding that you need. Like you said, this is one of the very big problems, right? When they make the syllabus, the IB should, of course, explain exactly what they expect you to learn.
Yeah.
A lot of times it's very subjective and not very clear what it is. So if you look at several different textbooks about the same topic, the same section, they will all have something different, which means you will look at one of them and say, okay, I should learn this. But then you look at the other book, oh, something different. You go to class, oh, wait a second, the teacher's saying something different. They're giving different examples because they understand the requirements a little bit differently. So this is one of the major reasons why people feel a bit frustrated when they feel like I haven't learned everything I should be learning, or I don't know everything I should know. One of the best solutions for that is if you analyze all the previous tests and the questions, what has been asked before, you have a better understanding of what they expect you to know. And you can kind of guide the students more into that direction so they don't lose a lot of time with maybe concepts that are not going to be in the test, or things maybe that interpretations that are incorrect. Maybe they're learning something that the IB did not mean you to learn. So one of the recommendations from the IB is you have to bring in people who have work experience so they can talk with the students about their own company experiences and what works, what does not work, what are common problems in the workplace. Up to now, I have not seen that happen.
Okay.
It's very hard to get busy working people to come to talk to the students. So, well, if the teacher has working experience, that's great. If he doesn't, then he will not be able to give the students a lot of real life examples. So a lot of the questions also come from that. They want to know, okay, in real life, what would be an issue for this kind of case? So the more experience you have and the more stories you've heard about those kind of cases, the better you would be off. I would say compared to physics, without any guidance, it's harder. If you have someone there to help you out with the studying, what to study and what to focus on, then it's easier. So a lot of students, the main reason they need help is because, yes, typically the theoretical part is hard for them to understand, especially because they don't have any personal experience in work. I would say 60% need more help in theoretical aspects, maybe 40% need more help in the coding aspect.
Okay.
So the best time if you want to prepare full-time, I would say, would be right at the beginning of the 4th semester. That would be the last opportunity where if you come, you have enough time to go through all the topics and all the theories. If you come a bit after the beginning of the 1st semester, but every month that you delay means we have to go faster and maybe skip a lot of parts. If you start earlier, we don't have to compress all the classes in a small amount of time. So you can spread out the classes and maybe do 1 class a week and just go with a tempo, right? Slowly go through all the topics. If you come back like in the 4th semester, then you basically have to do maybe 3-4 times a week. I like both physics and computer science equally, but if, as a given a choice, I would probably teach more computer science. And the reason for that is because computer science, it changes. And there's always more to learn. So there's always new technologies, there's always new things that come out so you can learn, there's new projects you can do with the students. Physics, on the other hand, is basically set. There are changes in the syllabus now and then, but mostly the concepts we learn nowadays are the same concepts we have learned for the last 20 years.